Oh, let me. So we've got our test one review. I put this practice test that we're going to go through together. And usually I think it's nice to try to give you time to work through it. But I also kind of think it might be nice to have a video of the solutions kind of start to finish. And so that's what we'll do unless you object and you want to have time to work through it on your own. But I see no objections. So I'm just going to push through it. And then I'll put out another practice test so that you can have a fresh one after you review the first one that we'll do today. So I posted this on Moodle, and the only thing it's hard because I don't know the length. Usually my go-to courses, I kind of have a good idea of, how long questions take. And I do have my rule where I take the time that it takes for me and then I triple it. And that's like a good time for you guys. And, but I wrote the questions. So I already know what I'm asking and stuff like that. And so I do try to read it properly. But besides that, yeah, that's why I triple it. It's not because I'm crazy fast or anything. Right? And it just gives you a nice buffer. So the only thing that I wanted to do was for the linear programming, the maximization and the minimization, I wanted to give you two options, right? It'll just be one of those, right? One of those two options. And then on the last page, it was an afterthought, just as it looks. But hey, I was going to give them the graphs. So then the graph for 10 and 11 is on the very back page there. Well, 11's kind of sneaky. Okay. So, and because I just whipped those together, I really hope they're the right graphs. We'll find out. I like to do kind of a list of core concepts. Oh, I forgot I haven't started yet. So we'll do review today. Test one on Tuesday. Oh my gosh, so fun. And then Thursday, I think we're all going to be sick, right? We're all just zonked from our test. There's no point in starting anything new. And then waiting reading break. We'd have to relearn it all. So no class on Thursday. Okay. You deserve it. You deserve a break. I know it's a busy time. And then you get your reading break. I'm sure I've already shown you, but it's so cute. I use it every term. And then we'll be back at it and we'll start with financial math. So I guess if you wanted to, you could take Thursday next week and start reading, I think it's chapter 6 or something. Why not? So we'll do some financial math once we get back. Okay. Any questions about that before we get started? So like I said, I'll just kind of run through these. I picked some questions from each section and put them all together. So what did we learn in chapter 1? We did linear equations, things like graphing a line. That came more into play later in linear programming, right, where we had to draw the feasible set and things like that. And so I'm not going to make you just graph a line, right? We made so many decisions without you.
Sorry.
You got it. Then we worked on finding the slope of a line. And then we worked up to using the slope to finding the equation of a line. Solving linear systems, finding the intersection of two lines. And then some application problems, right? Then we moved into linear programming, maximizing, minimizing, some objective function. That's a lot of work, right? And oh, that's what I wanted to do. I want to count out kind of roughly how many marks. It'll be one of these for 10 marks, that much I know. And let me just count. So this is an approximate guide of how many marks, usually just kind of one each. Some of these are harder than others, right? And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 16, 18, 20, 22 for chapter 1. That's a lot of little shorties. Right. Question? Stretching.
What would our formula sheet?
There were just some in chapter 1 that I highlighted, right? Do we remember what they were? I'll have to go through our notes. I think I made a note of what we were going to put. I'll have to sift through all our notes. I should have done it after class, but 6 o'clock, it's so late. I just want to go home, have dinner. So I'll do that and I'll post it on the wall. Okay, but anything you need, you'll have. Otherwise, just ask. Right. Okay. And then we did logic. Conjunction, that's the and, right? Disjunction is the or. Negation is the not. The conditional statement is the if-then statement. And then I'll give you what the converse, the contrapositive, and the inverse are, right, from a basic conditional statement. And then you need to rewrite it in words, right? I'll give you a conditional statement, just like we did in class, and then you have to rewrite it in the converse, the contrapositive, and the inverse, right? The biconditional is the if and only if. And then the truth tables, kind of fun. And then what does it mean to be a tautology and what does it mean to be a contradiction, right? Truth table ends up in all ones as a tautology, it's always true. And a contradiction, you end up with all zeros. And then the equivalence and the implication. The equivalence is the biconditional is a tautology, and the implication is a conditional that's a tautology. Kind of special cases. I'm not going to test you on that. Just up to here, I think. And how many marks do I have for that? 1, 2, 3, 4, 5, 6, 7, and 4, 11. Roughly. But I'm using this, to guide the way. Yeah. So we spent a lot of time in linear programming, only one question, but it is worth 10 marks, right? Because there's so many components. And I wanted to have kind of a lot of stuff, kind of low-hanging fruit from chapter 1, so that you can kind of show what you got, not just in one big mumba-jumba question, right? And then the logic, which I guess is kind of a lot of marks for only 2 days. We'll see. A lot of them are just like 1, 1, 1, 1, 1. Just 1, 1, 1, 1, 1. Okay. Oh, haha, nice try. When I was working through, before I posted the notes from last day, I realized that number 6 that I had given you was too hard. We hadn't talked about modus tollens, and so that's too hard. So don't worry about that. Just scratch it. If you were able to do it, cool. Not what I meant. And there was another typo not a typo, but I stole it from a different textbook and they use different words. And so number 4 should read, is a conditional statement using the terminology that we were using, equivalent to its converse, making it a lot easier. There. So only simplifying, not making it harder. I think that was it. All right. Are you ready for it? Do, do, do. Boop. Let's see here. I'm just going to add a page between, add some lines, and we're off to the races. Remember this? So cute, so fun. And yes, you get to do it on the test. For the line 3x minus y is equal to 12, complete the following ordered pairs. Now, of course, it implies that you know how to read these ordered pairs. Hey.
You were late too.
It's fun. I was just like, whoa, there's 4 over there now. Tricked me. It does imply what knowledge? It implies that you know that they're written like this, x comma y. But besides that, right, we're forcing x to be 2 and we're solving for y. And so in 3x minus y is equal to 12, you can plug in x equals 2. 3 times 2 minus y is equal to 12. 6 minus y is equal to 12. And then, fine, I'll just do it nice and slow. 12 minus 6 is 6. So y must be negative 6. That's showing a lot of work. You don't have to do that, right? As long as you tell me negative 6, right? You probably want to do some work, right? And just be careful, but you don't have to show all this work. No? 1 mark in the bag. Boop, boop. Got to catch them all. How do you get Pikachu on the bus? You Pokemon. I worked at a daycare for a couple of summers during the Pokemon phase. So why don't you shower with a Pokemon? Because he might Pikachu. Anyway, the daycare, so they're all pretty similar. 3x minus y is equal to 12. But now y is 6, and we want to solve for x. 3x minus 6 is equal to 12, making 3x 18, 12 plus 6. Six, 18 divided by 3. No, it's embarrassing.
Yes.
I better have my my emotional support calculator out. I'll need it just to have. 2 marks in the bag. I know. Will I say it after everyone? I don't know. X is 0? Same thing. Times 0 minus y is equal to 12. So negative y is equal to 12. So y must be negative 12. Don't forget that negative. But besides that, nothing crazy. What's some implied knowledge here? If x is 0, right, this makes it the y-intercept, right, where it crosses the y-axis. And so this is the y-intercept. Let me guess. Next, we find the x-intercept. Oh. Wow. Just wow. So now, when y is 0, oops. I'll try to make it. If y is 0, this is the x-intercept. Right, so some implied things here. 3x minus y is equal to 12. Kind of boring to use the same equation the whole time. But 4 pretty reasonable marks to be had. 3x minus 0 is 12, so 3x is equal to 12. X is 4. When x is 4, y is 0. And you could sketch this, but I'm not going to. We move on. Oh, maybe this is where I keep track of what we need on our formula sheet. Here's our first one. I'll do it in pink. Maybe. On your formula sheet, what are you going to have? You've got your, it's been so long, I don't even remember how we wrote the slope. Maybe y2 minus y1 over x2 minus x1. Does that kind of ring a bell, sort of? Nice. So on your formula sheet, you'll have that. And as long as you treat one point as 0.1 and the other point as 0.2, doesn't matter which one is which, right? And so here we go. Slope. It just asks you to find the slope, right? So not even the line yet. Way back. y2 minus y1 over x2 minus x1. Nine minus 3 over 5 minus 2. I'm going to try to keep it on this page here. Gives me a slope of 6 over 3 or 2. That's it. Now do it again with 2 new points. Same formula. Of course, y2 minus y1 over x2 minus x1. 3 minus 1 over 1 minus negative 1. Get a slope of 2 over 2. Gives me a slope of 1. You could probably do these faster than me. I'm talking about them. And that's got to feel good. question 3. I'll just do the whole thing. See? Determine the slope of the line from the given equation of the line. First one, not too bad. It is in the form of y equals mx plus b, and so I see that m must be -2. From y equals mx plus b. In part B, and I guess, I don't know why I wrote it like that. Oops. In part B, we have to do a little bit of rearranging, not too much, right? Unless you remember that it's, what was it? -a/b. If it's in the standard form, you don't have to remember that. You can just rearrange it into y equals mx plus b is probably the easiest. And so 2x minus y is equal to 6. And so -y is 6 minus 2x. So y is -6 minus 2x. Or y is -6 plus 2x. Therefore, the slope is 2. Right, whatever is attached to the x is the slope. Which is the same as -a/b, -2/-1. Right. Or from ax plus by is equal to c, m is -a/b. I'm not going to put that on your formula sheet, but if you want to remember that, that's cool, but I don't expect you to, right? You can rearrange it and it's fine. Okay. Right, an equation of the line satisfying the given conditions, right? The equation in the form y equals mx plus b. It passes through the point 310 and has a slope of 2. Yeah.
Sorry, so for ax plus by equals c, you ever ask for that version? You just want to get the constant to the equivalent. So x, y on one side.
Yeah, exactly. So you move all the x's and y's over to one side and then the c on the other side. I think I have one coming up and maybe that's where you are. Yar. Write an equation of the line satisfying it passes through the point 310 and has a slope of 2. There's a couple of different options, right? Let's brute force it, right? Y equals mx plus b is always going to work. So that's what I mean by, so from y equals mx plus b, we're told that the slope is 2. So then here, the slope is 2. So I can start there, 2x plus b. And then I need to use that given point that's on the line, right? That's an xy coordinate on the line, and I can use that to solve for b. So now I plug in y is 10 is equal to 2 times 3 plus b to solve for b. 10 minus 6 means that b must be 4. Therefore, y equals 2x plus 4. Or you could use the point slope formula, Right. I can't remember if I said I would give it to you.
Yeah.
Then I'll do it in pink. Y minus y1 is equal to m times x minus x1. That's the type of confidence that's going to get you stuff on the formula sheet. Oh yeah, you said. I think I did though. I did. So you could use the point slope form of the line, and you could say, okay, well then y is going to be y minus whatever the y is here, y minus 10 is equal to 2 times x minus 3. And then you kind of move it into the y equals mx plus b form by saying y is 2x minus 6 plus 10. So y is 2x plus 4. Either way will work, right? You don't have to do both, obviously. I didn't declare it, but I'm trying to only use the dark blue just for kind of your everything that you kind of need, right? You don't need to show all those steps, but everything you need to solve it. And then all the other colors are kind of extra. And pink is for the formula sheet. I have to remember that though. We'll see. Okay. How about B? B's just a slight level up. It's only worth 1 mark, right? Same as the other ones. So what you'll find is that there are some 1 markers that are worth more than others. I guess this one should probably be 2 marks. Why? You'd have to find the slope first and then find the equation of the line, right? Kind of a 2-step process. We'll do it, and then you can decide if you want to up it to 2 marks or keep it at 1 mark. Just depends on how confident you're feeling. Oops. M is y2 minus y1 over x2 minus x1. We'll start there. You always need to start by finding your slope. So we have -1 minus 5 over 2 minus 3. -6 over -1. I have a slope of 6. And just so it doesn't take up a huge page here, in y equals mx plus b, I have y equals 6x plus b. You'll stop me if I do something weird in my slope, right? It's gonna haunt me. Pick either one of these points. I usually pick the first one, just for consistency. So y is 5, 6 times 3 plus b, and 5 minus 18, I had to check that it was 18 first, gives me a b of -13, which means that y is, y is 6x minus 13. Do you want it at 2 marks or keep it at 1 mark? Depends on how good you feel about it. Sometimes if I feel like, it's kind of a tricky question, I don't want to make it worth too many marks. But if it's something hard that I know you can do, then I bump it up. One's like, how about 0 marks? 100 marks. 1. You can think about it. Let me know. Otherwise, it'll stay at 1. Write an equation of the line satisfying the given conditions. Write the equation in the form ax plus b equals c. Right, so now in standard form. We can use our standard starting point, y equals mx plus b. And we're told that m is 2. Let's see here. No, I usually do this. 2x plus b. And then I plug in my point, which is when y is -1, x is 3. So 2 times 3 is b. -1 minus 6 means that b is -7. Which means that y equals 2x minus 7. But that's not the form we want. We want it in standard form. Ax plus b, y is equal to c, which means I have to move all my x's and y's over to one side. In this case, it's not a crazy move, right? I'm going to have -2x plus y is equal to -7, right? Just to match the x and then the y. I'll highlight the order there. Or you could, because you have a point, 1 point and the slope, it might be easier to start from y minus y1 is m times x minus x1. But as you saw, you can always start at y equals mx plus b and find your equation of the line. But then you would get y minus -1 is 2 times x minus 3. So you get y plus 1 is equal to 2x minus 6. And then you still have to move things around. -2x plus y is -7. It does mean that you're comfortable working with the point slope form of a line, which is, not necessarily the case, but it'll always work if you just start at y equals mx plus b. B. So again, kind of ramping things up. First, you have to find the slope and then use one of these points to find the equation of the line. Doesn't need to be quite that big. M is y2 minus y1 over x2 minus x1. 1 minus -3 over 5 minus 2. 1 plus 3 is 4 over 3. Ooh, tricky. It's okay. Oh, disappeared. So then, I go up here, y equals mx plus b. I get y is 4 over 3x plus b. Plugging in one of those points, And like I said, I just tend to go for the first one. -3 is 4/3 times 2. Plus b. I wanted these to. So. I was kind of flying blind here. I don't want you to have to deal with fractions, but maybe it works out. B would be -3 minus 8/3. Is 8/3 anything nice? No. Nothing nice at all. Did I do something weird? 1 minus -3, 5 minus 2. The slope is 4/3, right? I feel like they were canceling before. Oh, well, we'll do it. But I'll make a note. We can do it. It's too hard. This part, not expecting this. That's what I get for just randomly picking them values. Or questions, I should say. That's okay. What do you have to do? Combine fraction or subtract two fractions. I need a common denominator, which means that I need -3 times 3/3 minus 8/3 is equal to b. -3 times 3 is -9/3, which should simplify to -3. It does, right? And so that was the goal. But now I'm able to subtract 8/3 is equal to b. -9 minus 8 is -17/3 is equal to b. So then that puts us at y equals 4/3x minus 17/3. But we want it in standard form, which means I have to shuffle these values over here. Yeah.
What spot is before moving from -8/3 to the same side is multiplying by 3. I'm okay to do that before I cancel it out before I switch around.
Yeah, you can. As long as you do it to all the values. So as long as you're doing this times 3, then you get -9 is 8 plus 3b. You're allowed to do that. And maybe that's a better way to do it. I'll stick to my guns. And I'll make sure that there's no messy one on the test, obviously. But from here, -4/3x plus y is -17/3. You end up kind of doing the same thing. If you multiply this 3 over to the other side, you get 3 times -4/3x plus y is equal to -17/3 times 3. So then you get -12x plus 3y is -17. Same thing. I'll make it easier. And it was only 1 mark. Eek. That's not true. That was at least 2 marks worth of work. Especially when you see this one, that is 2 marks. So now we move into our word problems. We're going to create linear functions. They're the same as what we've been doing, right? We need to either find 2 points, or we have the slope and we have a point, and we can create the equation of the line. And so the variable cost to manufacture an item is $20 per item. And it costs a total of $750 to produce 20 items. If X represents the number of items manufactured and Y is the cost, write the cost function. So then Y is the cost, which is going to depend on X, right? And so now it's $20. The variable cost is $20 per item. And so that means that it's going to cost 20x, 20 times however many items I need to produce. And we're not told what the fixed costs are, but we are told plus B, because we are told that the cost, so Y, to produce 20 items is 750, right? And so we're given 20 and 750. So now we can use that to solve for B, just like we were doing. And so now I have 750 is 20 times 20 plus B, and 750 minus 400 makes 350 is equal to B. And I usually write those in the other order. B is 350. Therefore, Y is 20x plus 350. I like those 2 marks rather than the previous one, which is only 1 mark, but that was a mistake. This should be 0. Nice. And I like to keep the topics all in the same order that you saw them on the test, just like we have them here, right? Because otherwise it can get kind of confusing, but also it could help you figure out, okay, this is what we were doing at this point, right? And so I like to keep them in the same order that they appeared. A person who weighs 150 pounds has 60 pounds of muscle, and a person that weighs 180 pounds has 72 pounds of muscle. If X represents the body weight and Y the muscle weight, write an equation describing their relationship. And then use this relationship to determine the muscle weight of a person that weighs 170 pounds. So we're told that X is the body weight and Y is the muscle weight. So we're given if X is 150, then Y is 60. And if X is 180, then Y is 72. So we're given 2 points and we want to find the equation of this line. same as before. M is y2 minus y1 over x2 minus x1. Always have to find the slope first, unless it's given. 72 minus 60 over 180 minus 150. Puts me at 12 over 30. Please be something nice. 0.4. Phew. Something nice. So then y equals mx plus b means that y is going to be 0.4x plus b. Pick either one of these points, like I have been doing, I'll just pick the first one. 60 is 0.4 times 150 plus b, solving for b. Now, 0.4 times 150 is 60, and so b, 0. Which means that y is 0.4 times x plus 0. That's optional. You don't have to write the plus 0. And there was a follow-up. Use this relationship to determine the muscle weight of a person that weighs 170 pounds. So now x is 170. Right? Kind of implied that you can map that, I guess. And so then at x equal to 170, y is 0.4 times 170. 170 times 0.4, 68 pounds of muscle mass. Or pounds of muscles. Then we moved on to talk about how to find the intersection of two lines, right? And so we'll start off nice and slow and just, I give you two lines and you find the intersection. Solve for x and y. This is the intersection, right? Kind of implied knowledge. Find the intersection. When they're set up like this, right? We looked at a couple of different ways, but I'm just going to set the y's equal to each other and solve for the x that makes that happen, right? And then I can solve for the y. And so if I have 3x plus 4 is equal to y, but y is also supposed to be equal to 5x minus 2, right? Then I can bridge those equal signs. And I can say, okay, well then in that case, 3x plus 4 must be equal to 5x minus 2. And then I can solve for x. Moving all my x's to one side and all my y's to or all my constants to the other side, I'm going to move, I like to move all my x's to the left. So I get 3x minus 5x is negative 2 minus 4. So I get negative 2x is negative 6, which means that x must be positive 3. both of these equations have to give the same value for y, right, at x equals 3, because that's the point of the intersection. And so if you have y is 3x plus 4, then y is 3 times 3 plus 4, which is 13. Or, but I like to do it just to check my work. 5x minus 2, 5 times 3 minus 2, again, puts me at y equals 13. You don't have to show both, as long as you're confident, you don't have to. So therefore, x is 3 and y is 13. Okay. Any questions while I scroll? All the way back up here. Did a lot. We're almost on the next page. A car rental company offers two plans. Plan 1 charges $10 a day and 10 cents a mile, or per mile, probably. While Plan 2 charges 14 cents a mile, but no flat fee. If you were to drive 300 miles in a day, which plan is better? Means we're gonna have to find equations for each of the plans. And so Plan 1 looks like what? The overall fee, let's call it y. Let x be the number of miles per day. So for each day, oh yeah, if you were to drive 300 miles in a day, there it is. Otherwise, we'd have a variable component on the $10 per day. No thanks. I know that's not what they meant. So now, Plan 1 charges 10 cents per mile. 0.1 times x. Right. Careful with the 10 versus 0.1, right? Because then we're gonna have $10, and so the cents need to be in pennies, right? And then plus $10, and that's per day. Versus Plan 2 has the same layout, but they charge 14 cents per mile, but no flat fee, right? So plus 0. So now we have 0.14x plus 0. You can drop the 0, but it's nice to show it. If you were to drive 300 miles in a day, which plan is better? Plug in x equals 300 in both of these and pick the lowest cost, probably, right? And so here, start part A, let x be 300. Plan 1 is going to cost y equals 0.1 times 300 plus 10. I get 40, but I might have dropped a 0. No. And versus Plan 2, 0.14 times 300. 42. Therefore, bless you, plan one is better if driving 300 miles. Oh, dang. I felt that somehow in my feet. That's weird. Part B, I'll put it on its own page here. For what mileage are both rates equal? And so what value of X makes both of these rates equal? Well, that's the same as saying, well, where's the intersection, right? The intersection. So we have 0.1x plus 10, and I'm going to force it to be the same as 0.1 for x, and I'm going to solve for x. Moving my 0.10x minus 0.14x is equal to -10, shuttling things over. Then I get 0.1 minus 0.14 is -0.04 times x is -10, which means x is -10 divided by -0.04, which puts me at a nice clean 250 miles. Yeah. Presumably, right, if we think about, this is just kind of background, but if you have two lines like this, right, they're increasing. I should have done these better. Let's do, no, I did my first one bad. I can't get there. There, drew a little curve. Then here, this is the intersection, right? And so up to the intersection, x equals 250. I'm using pink. That's not on our formula sheet. Maybe that's implied. You'll figure it out. I'll erase it. How about that? All right. So up until 250, one plan is going to be better than the other one, just consistently. And then after 250, then the next plan will be better. Since we know after 250 at 300, plan one was better, then it stands to reason that plan two is better up to and including 250, at where they are the same. And then from 250 or more, you should use plan one instead. Where's that on the test? It's not. You could even find where what the rate would be, but it doesn't ask you for it. So don't have to. Hey. And that's the end of chapter 1. An hour or so in. Just for timing. More for myself. I've been blabbing a lot. You just get to sit down and do it. It'll be done in no time. So this one is where I should have included the graph in here, but I'll go grab it from the very last page here. And I really hope I did a decent job. sketching these out. It's running out of time. Farmer has 100 acres of land on which she plans to grow wheat and corn. Each acre of wheat requires 4 hours of labor and $20 of capital. $20 of capital. And each acre of corn requires 16 hours of labor and $40 of capital. The farmer has at most 800 hours of labor and $2,400 of capital available. If the profit from an acre of wheat is $80 and from an acre of corn is $100, how many acres of each crop should she plant to maximize her profit? Now you don't want to mix these up because I've used X and Y, the order that they appeared, which means, let's do maybe this here. First thing we do, we want to maximize your profit. And your profit is 80 times however many acres of wheat. And so we've got 80 wheat and 100 for every acre of corn. I use this to let me define what my X and my Y's are, right? So then let X be the number of acres of wheat and Y be the number of acres of corn. That is kind of an aspect that I do want to test you on, but if you're unsure in the test, you can call me over and ask me if it's right. Okay, I'll kind of nudge you if it's wrong. But as long as you read it in the order that it appears in the question, you'll be safe, right? Because if you switch the X's and Y's, it's going to make a mess, right? So that's why if you want to ask, that's great. Can I squeeze that up there? So then I need my constraints. What are my constraints in this case? She only has 100 acres of land. Don't forget about that, right? And so the total X plus Y then has to be less than or equal to 100. She can use less than the 100 acres if she wants to, but that's probably not going to maximize profit. Each acre of wheat requires 4 hours of labor and $20 of capital. So this is one of those situations where you get constraints on the labor as well as constraints on the capital, and you want to tease those out, right? And so here, this is a constraint on the number of acres, and then we have constraint on the labor and constraint on the capital. $4 hours per acre of wheat, so 4x. And then for the corn, 16 hours of labor. Whoa. 16y. And she can use at most 800 hours of labor. So it's less than or equal to 800. For the capital, $20x plus 40y. And she only has 2,400. Shouldn't say only. We need to figure out, well, in this case, you don't actually need to figure out which line is which, I guess, because they're all less than. right? And so they're all going to be below, which means, and of course, I keep forgetting, x has to be greater than or equal to 0 and y has to be greater than or equal to 0. If you forget to write those, that's totally fine. It's kind of implied. I won't take marks off. So that means that we're going to be below each of these lines. But I still need to find the intersections, right? So I need to figure out which line is which. So what can we do when we live in a shoe? If we look at x plus y is equal to 100, right? So we've got these inequalities and we do want to check in on those inequalities later, but we already decided that it's all going to be below each of these lines, right? And so we already know the feasible set, right? But to find the feasible set, the intersections or the vertices, we need to know which line is which, right? So that's what we're doing next. So if you set these inequalities equal to equal signs, then you'll have the lines. And you can solve for y equals mx plus b and try to figure out, well, a go-to move, right? Let x be 0, y is 100. That settles it. I think this red line is the first constraint. So then here, y equals x plus 100. Oh, thank you. Do you have to do it in a self-punishing red? No, that's just for the notes. These are the solutions. There, I'll make it more clear. Thank you. Okay, on to the next one. What if we have 4x plus 16y is equal to 800? Right, trying to map it to one of the two remaining lines. 16y negative 4x plus 800. So y is negative 4 divided by, I'll do it properly, divided by 16, negative 0.25. Check. Is and 800 divided by 16 is 50. Again, because we have our axes, right? Here, this blue line has a y-intercept of 50. So if I let x be 0, y is 50, telling me that this line here must be y equals negative 0.25x plus 50. Which means the green line is the leftover one. I'm going to rewrite it in terms of y equals something, because then it's easier to manipulate later. And I'll need a page. Or maybe I can I scooch? So you can see them all side by side. 20x plus 40y is 2400. y is negative 20x plus 2400. But overlap them. Gross. But it is nice to have them all together, I guess. Looks almost normal. y is negative 0.50x plus 2400 divided by 40 is 60, which checks out. Right, 50, 60, 70, 80, 90, 100. So now this line here is y equals negative 0.50x plus 60. Like we said, all of these have to be below the line, right, on this side. And if you're not sure, you can pick a test point and see if it satisfies the inequality. But what we're going to find is that the feasible set, oh, let me pick a nicer yellow here, is this area, right? X and Y still have to be greater than 0. And now I have to find these vertices. Labeling them A, B, C, D, E. I have to find all these vertices. I know A, I know B. You're okay to jump to B. And I'll even let you jump to E, which is where at 0 or at 100 and y equals 0. But you do need to find C and D. So for each vertex, A is at 0, 0. B was at 0, 50. C is the intersection of, let's see here, the green line and the blue line of negative 0.50x plus 60 and negative 0.25x plus 50. I don't know why I dropped the y. Can solve for that intersection. Setting them equal to each other, I get negative 0.5x plus 60. I think that's what I was jumping to. Negative 0.25x plus 50. X is to one side. Negative 0.50x plus 0.25x is 50 minus 60. Negative 0.25x is 10. 10 divided by negative 0.25 x is not negative 10. 40. I got negative 40. That's wrong. 10 minus or 50 minus 60 is usually negative 10 and not 10. Let me confirm. So at x equals 40, and you've got the graph, so you can check to make sure that that looks reasonable, right? But for these kind of floating vertices, you do have to show your work, right? And so now we need to find the y value. So y, oops. Y is negative 0.50x plus 60 at x equals 40. Negative 0.5 times 40 plus 60. Y is also 40. So then, oops. 40 is the intersection for C, and you can check to make sure that that looks reasonable. And it does. D is the intersection of two lines. Which ones? D is the intersection of negative x plus 100 and y equals negative x plus 100 and y equals negative 0.50 x plus 60. Same thing all over again. Negative x plus 100, negative 0.50 x plus 60. Solve for x. Negative x plus 0.5x is 60 minus 100. Negative 0.5x is negative 40. Make sure I don't mess that up again. Negative 40 divided by negative 0.5, x is 80, which I'm pretty sure checks out with the graph, which means that y is negative x plus 100. So y is negative 80 plus 100. Y is 20. So then 80, 20 is that vertex. I guess this is a good time to say, so if you have a calculator that solves for these intersections, which I know mine does, a lot of them do, and you use your calculator, that's fine, but you have to write me a note. Using my calculator functions, I found this to be the intersection. And so there, you can spend all your weekend figuring out how to make your calculator do it, or you can just do it. It's up to you. I know everyone's like, wait, what? Wait a second. You'll have to Google your way to it. It is too much work. For me, it's too much work. I did have someone show me how to do it, so that's kind of cool. And then E. Is I don't need you to show me this work when y is 0, x must be 100. So you can just say it's at 100, 0. Next up, at each vertex, evaluate that, what would, we called it the objective function. A, B, C, D, E. I'm just squeezing it in on this page here. A was at 0, 0, B was at 0, 50, I want to say. 40, 40, 80, 20, and 100, 0. Then the profit the profit better than not coming at all. 80x plus 100y. Here you get 0 profit. Here you get 5,000 profit. I better do it. 100 times 50. Phew. Okay, this one I better jot down. It's 40 plus 4,000. Times 80. Plus 2,000. And I'm gonna go for D. I want to maximize my profit. Therefore, profit is maximized to 8,400 at X equals 80 and Y equals 20.
I find this easier than chapter 1.
Really?
Yeah, this is much easier.
I just
for me
feel
than
like
chapter
once
1.
you're actually applying material, it makes more sense.
Hmm.
Then you see the goal
Yeah.
versus when you're doing it, it's just like, I don't know. what
I'm given the numbers in chapter 1. I'm like, I don't know what I'm supposed to do, but I know how to.
That's so interesting.
I feel like it's always been like that for me.
Mhm.
So I don't see the bigger picture until later. And then it's like, I'm just
That's why,
making
so I was
sense.
pushing so hard. I was like, should we just do this? Let's just do this.
It all builds on chapter 1. So you know chapter 1.
I know it, I just don't know how to read it.
Yeah. Oh my god, the questions that came out of words.
But like this is great.
And this you won't probably have seen it unless you've done the chapter review questions as well. No. So kind of exciting to see one that you haven't seen before.
Crazy.
Only 2 lines too. What? What? Well, there's a little tiny curveball. How about we keep going and we'll come back to this one and let you work on it. Since you haven't seen it before, it's kind of exciting. All right. What a thrill. Into logic. Consider the conditional statement. If I show my work, then I can get part marks. Can get full marks too. First, write the converse as a sentence, then write the inverse as a sentence, and then write the contrapositive as a sentence. Now, I'll do it in pink. On your formula sheet, you'll have if P, then Q. Or I guess if P, then Q doesn't really make sense, but given if P, then Q. Then the converse is which one? I better grab it from somewhere. Oh. Then the converse is if Q, then P.
Those are not the cheat sheet.
Yeah. The inverse, that's why I didn't memorize them. Oh, weird, I did them in a weird order. Anyways, not pew, not pew, pew pew. Not P, then not Q. And the contrapositive is some mashup of that. If not Q, then not P. And that'll be on your formula sheet. So you need to map these to if P, then Q. I'll show my work can be P, or you could use S or W or something fancy, but might get tricky mapping it back to the conditional statement. I can get part marks can be Q. Now it's a matter of mapping these statements right, into the converse, which is this one. If Q, then P. If I get part marks, then I showed my work. The inverse, not P, then not Q. If I don't show my work, then I can't get part marks. Can't get part marks.
That sounds weird.
If I don't get part marks, then I didn't show my work.
Mhm. Yeah. I'll keep it as close to if I some of these get pretty weird. Yeah. Then
But you won't be like super logistical. Like as long as you
no,
get, like,
as yeah.
and the
In fact, yeah, I'm gonna make this kind of sound clunky, but kind of in the cleanest negation kind of way. You're allowed to do the same, right? You don't have to clean it up or anything. If I can't get part marks, then yeah, I will not show my work.
I will not.
I will not show my work. Where was it? Below. Let MB, I like math. Let P be, I will pass this course, and let A be, I will do my assignments. Express each of the following prepositions in symbolic form. I like math, and I will pass this course. You can. Got this.
And
Oh, that one's sneaky. I like math, and I will pass this course. M and P. I will do my assignments, or I will not pass this course, assignments, or not P. This one's weird. It is not true that I both like math and will do my assignments. So I like math and will do my assignment is not true. Hence the brackets. That's kind of the sneaky one. I will not do my assignments and I will not pass this course. Then they're separate. Not A and not P. There's no.
we just have questions 10 through 14. Those are great. Yes. Mostly.
You can just power through those other ones. And then finally a truth table. But it's just an itty bitty one. Yeah. Maybe it's kind of disproportionate. Now, why is this one 4 marks? Well, you have to set up your truth table. And then you have to build it out. And then you have to explain if it's a tautology, a contradiction, or neither, and why.
Okay.
So 4 marks. I'll build it here quietly. A contradiction is if you get all zeros. So a tautology is all ones, and a contradiction is all zeros. And then neither is a mashup if you end up with a mashup.
Okay, no, that's
Not too bad.
No, it's not.
Nice. So we start off with.
The biconditional is almost easier than the conditional, right? The conditional has that special weirdo case.
So my question is, if I put for the Q, put 1010, and you mark wrong for that, does it have to be 010?
Well, you'd be making me work pretty hard. It's fine. But if you try to follow and always start with the zeros, that's good.
I will do my best, but I cannot do it.
That's fair. And then I get 0, 1, 0, 0.
What the explanation of five conditional be?
No, it just gives me the-
Mhm. The biconditional has to bounce between the same values for it to be a 1.
Okay, so they both have to be the same. thing.
Oh.
Right.
So, yeah, so you have to bounce between the same thing. Yeah, so you can bounce between 2 zeros or between 2 1s. Everything else is a 0.
No halves.
No halfsies.
And it's neither.
It's neither.
Yes.
And the explanation is, since it is not all 1s nor all 0s. Nice. How's that? That's pretty good.
It's not bad.
I think that's a pretty good length for a test. Can do it all over again on Tuesday.
Chapter one.
I'm gonna stop the recording so that if you want to, you could work through Mr. Boutros's investment fund. Or I'll post it in the solutions either way. If you have any questions, let me know. Otherwise, see you